Hello everyone, welcome to today's webinar. Today we will cover the first section of Unit 5, Quadratic Equations. Today we're going to look at how to factor multiple kind of monomials, binomials, how to factor using different methods that we're going to learn today. Make sure that you register for next webinar, which is going to speak about the second section of Unit 5 for Algebra 1. This is myself. My name is Mariam. I'm your math instructor here at Penn. I am certified to teach high school math in the state of Pennsylvania, and I also earned my master's degree in education this summer. Today in this webinar, we're going to look at the most challenging topics in the first section of the Unit 5 Quadratic Equations. Throughout the webinar, you're going to see that some questions are labeled self-check. Those questions are provided for you to assess yourself on a certain topic that we discuss together. So those questions are not graded. It's not an assessment of you made by us. It is provided for you to assess yourself. So please participate in those questions whenever the time comes for them to be the next thing to do in our webinar. Also, questions are welcome. You need to keep your questions relevant to the webinar so we are able to finish all of the topics that we are planning here today to cover. So if you want to ask your question, you want to type your questions in the questions box. I'll be able to see your question and who asked the question. Also, all registrants for this webinar will receive the recording in a follow-up email. Whether you attend or not, you will receive a recording of this webinar to keep and watch at your convenience. Today, as I said, we're going to look at different methods of factoring monomials, binomials, and we're going to look at a bunch of different ones. It's scattered around the unit, and I thought just to bring them together in one webinar. Next webinar, we're going to look at how to factor trinomials and how to solve quadratic equation, which is the ultimate goal of that unit, to learn how to solve quadratic equations using factoring. So before we are able to get into the depth of how to factor a polynomial, for example, we need to start step by step developing on the basics that we need to learn and master before we go ahead and move to the real things here. So the first thing we need to remember together, if you remember in elementary school, we were asked to find the GCF, the greatest common factor between two numbers. The same process we're going to do on numbers and variables later on, but we need just to refresh our memory on how to do that because we will need to find the GCF of numbers and variables to be able to find the greatest common factor between two polynomial terms, and that would be the basis of our factoring. Also, on my slides, you will see that section that will have a summary of the rules or how to do things in simple steps. So you can keep that on the side of your notes or notebook if you keep one for this course. And instead of just going back and forth in the unit and trying to find what to do in a certain situation. So let's start by just remembering how do we find the greatest common factor between two numbers, 28 and 18. And just to make sense of what is the greatest common factor, what does it mean? We know that each number, if it's not a prime number, it has a bunch of factors. So 28 has a bunch of factors. Some of those factors are prime factors. And the prime factors, you know, a prime number is a number that does not have any other factors other than itself and 1. So for example, 2 is a prime number because 2, the only factors for 2 is 2 and 1. 3 is a prime factor. 5 is a prime factor. 4 is not a prime factor. Our job is to break down each number, 28 and 18, into its prime factors. And then find the common, the shared prime factors between 28 and 18. And these would be the greatest common factors. We multiply them together and will give us the one greatest common factor between 28 and 18. Let's do that together using math instead of just speaking about it. So I like to use the tree method, a tree method. I'm going to break down 28 into a tree. I know from my knowledge of the multiplication table that 28 is a multiple of 7. I know that 4 times 7 is 28. So I'm going to put 4 and 7 at the leaves of this tree. But I know that 4 is not a prime number. It means that there are more factors I can break 4 into. So I'm going to make 2 branches for 4. 4 is actually 2 times 2. Now look at the leaves of that tree. So 4 is not a leaf anymore. 2 and 2 and 7 are the leaves. They are the ends of the branches. So we call them the leaves. The leaves are the prime factors. If you cannot break down 2 and 2 and 7 into any more factors, then this is your prime factors that if you multiply them together, you will get back to the 28. So the prime factors for 28 are 2, 2, and 7. Now I need to see what is common between 18 and 28. So let's do the same thing for 18. A tree, and I know from my knowledge as well that 6 times 3 is 18. 6 is not a prime number because 6 is actually 2 times 3. Look at the leaves and I realize that 2, 3, and 3 are prime numbers, prime factors. So that's it. I'm not going to extend my tree anymore. So I'm going to circle those leaves, and this would be the list of my prime factors that when you multiply them together, you will get back to 18. So I'm going to list them there. What I'm going to do to make it easier for myself to recognize the common prime factors between 28 and 18 is that I'm going to list the common factors on top of each others. So I have a 3 here. I'm going to put it outside here, just not under this set of factors because I don't see a 3 here. But I have another 3 that's not there on the 28. So the only common one is 2. I'm going to put 2 under 2. The only common factor between 28 and 18 is 2. 2 is the only common factor. So the GCF of 28 and 18 is 2. So the GCF equals to 2. We're going to use that later on when we factor polynomials. So we just need to master how to do that with numbers. Some of you, when you look at the two numbers, you're able to say, well, 28 and 18, only 2 is the greatest common factor. You can do that as well if you're sure that there's no greatest factor than 2. But you are able to use your knowledge, your experience to find the GCF. I'm just showing you a manual way that you can go to whenever you have weird numbers that you're not able to right away say what is the common factors between them. Let's look at another example. We're trying to find the greatest common factors between 36 and 105. I corrected that on my paper to be 100 just to make it easier for us. I'm going to make that 100. So now we're looking for the greatest common factor between 36 and 100. That is a tough one because I do not know exactly what would be the greatest common factor. So I'm going to use my tree method. So 36, it's going to break down to a tree, and 100 will be broken down to a tree. For 36, I know that 6 times 6 is 36. I know that 6 is not a prime factor because 2 times 3 is a 6, and 2 times 3 is another 6. The prime factors is 2, 3, 2, and 3. If you multiply them together, you will get back the 36. That's how you know that these are all of the prime factors of 36. I'm not done. I need to do the same thing for 100. 100, I know that 100 is, you can go with 2 times 50. You can go with 5 times 20. I'm going to do 5 times 20. You can try it as 2 times 50 if you want. 5 is a prime factor. It's not going to be broken down to anything else. 20, though, is 4 times 5. 5 is a prime factor, but 4 is not a prime factor. It's 2 times 2. Let's circle the leaves. These should be prime factors. 5, 2, 2, and 5. Let's list the factors of 36 and 100 on top of each others, and that way we're able to see the common factors, and then we can determine the greatest common factor between these two numbers. So I have, for 36, I have 2, I have 2, I have 3, and I have 3. For the 100, I have a 5. It's not common. I'm going to put it away from there, and 5. And I have a 2 and a 2. So 2 and 2, both are common factors. Multiply them together. 2 times 2 is 4. 4 is the greatest common factor between 36 and 100. So 4 is the greatest common factor. Any questions? Anything that was not clear on how to find the greatest common factor between two numbers? Again, if you have just joined us to the webinar, you're able to type in your questions in the questions box. The raise your hand feature does not work in our webinars. Okay, let's move on to a self-check question. How can we find the greatest common factor between 56 and 60? As I said, some numbers are a little bit tricky. You cannot just determine what's the GCF right away. You have to do maybe the tree. So I'm going to leave you with that question, and I'm going to actually put it up because I have the full question written out in my other screen, and you'll be able to actually enter your answers. And honestly, I'm not gathering information or stats on who did the question wrong or correct. I just want you to practice, and I want you to assess yourself and determine yourself if you need more help on that topic or you're okay. You can move on and you think that you're good in that topic for the exam. So here's the question, and you can take about 30 seconds to think about it and share your answers. Here you go. Okay, for those questions, I'm going to share my answers, and I'm going to probably do that question with you. I usually do not. I just give you the final answer, but I want to give you one more time how to do the tree method. So I'm going to go ahead and show you the answer. The answer is C. 4 is the greatest common factor between 56 and 60. How did we get to the answer? The tree. For me, I prefer to do the tree if I see numbers that it's not common for me to determine the greatest common factor. 56. I know it's 8 times 7. 7 is a prime factor, so that would be a leaf. But this one should extend 4 times 2. But 4 is not a prime number, so it's 2 times 2. So far, 56 has the factors of 7, 2, 2, and 2. Now let's go do the same thing for 60. 60, you can think about it as 20 times 3, or 30 times 2, or 6 times 10, whatever you want. You want to end up with the same answer, 6 and 10. 6 is not a prime factor, it's 2 and 3. But 10, 2 is not a prime factor, it's 5 and 2. Now all of them are prime factors. The prime factors for 60 are 2 and 3 and 5 and another 2. So I have a 2 common and I have a 2 common, multiply them together. So your greatest common factor is 4. And that's why your answer is C. Any question on this self-check question that we have just done together? Okay, let's move on to how then do we find the greatest common factor of two monomials? So a monomial is a bunch of variables multiplied together. So x to the third times y to the sixth power, this is a monomial, and this is another monomial. What is the common factor, the greatest common factor between these two monomials? So the rule for that, we're not going to do the tree. I mean, the tree method is valid with variables as well, but there is another way that I find easier than breaking down the, I'm going to show you that just to show you why the tree method is not wrong, but it's going to be a hassle to do that. So you're going to break up x to the third and y to the sixth to this. 1, 2, 3, x, 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 because you have 3 powers, and then 6 branches because you have y, 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 and y, and y, another y, to make them 6. And then you get the same thing for here. And then you're going to know how many y's and how many x's are shared, and then you're going to write them as your final answer. Another way that I find so easier than that is to look at the common variables between monomial number 1, monomial number 2. So x appears here and there. Which one has the lowest power? X to the third is the lowest power. Then x to the third would be part of our GCF. Also, I see a y and a y. 1 raised to the 6th power, 1 raised to the 2nd power. I always go with the lowest power. So y to the 2nd would be part of my greatest common factor. Nothing else I'm looking for. So your greatest common factor is actually x cubed times y squared. And that is written out here in this rule, that you combine the common variables with lowest powers. So that would be your greatest common factor when it comes to variables only. Let's look at question number 2. X to the 5th y cubed z and x y to the 10th z squared. So I see that each variable appears once in each monomial. So all of them are common. Now, which powers those variables will take? The lowest power. So I have x to the 5th and x. I'm going to take the x. X to the third and x to the 10th, y to the third and y to the 10th, then y to the third, it's the lowest power. Z to the first, of course, and z to the second, then z would be part of our greatest common factor, and that would be your final answer. That's it. It's easier than the tree method in this case when you only deal with variables. Any questions here? Anything that was not clear? Okay, let's move on to the next slide. Let's do more complicated monomials. I have numbers, variables, raised to powers, and another monomial with numbers, variables, and powers. Now, we learned how to find the greatest common factors for numbers and how to apply rules for finding the greatest common factors for variables. So we're going to do both rules. Now, I see 70 and 21, so I'm going to deal with the numbers first. So if I'm so knowledgeable about the numbers, I would say from the beginning that 7 is the greatest common factor. You can go ahead and do the tree, but you will find that 7, using the tree method, that 7 is the greatest common factor between 70 and 21. So 7 is going to be in our greatest common factor. Now, what's left is the variable part. The rule that we applied is whatever common variable that you see in both monomials, take the one with the smaller power. S does not appear in the second monomial, then S is not common. I'm not going to have S as part of my answer. T and T, 1 to the 6th and 1 to the 2nd, then take the one with the lowest power to the second power. R and R, I have R to the first. Remember, we do not write 1 in algebra. So R and R to the 5th. So R would be part of our greatest common factor, and this would be your final answer. 7t squared R is the greatest common factor between this monomial and this monomial. One more question, 12 and 144. Right away, I know that 144 is a multiple of 12. 12 times 12 is 144. So I know that the greatest common factor is 12, but you can try the tree method if you want to make sure. So 12 would be part of our answer. Let's look at the variables. Q and R Nothing there is common, so there is no variable part of our answer. The only greatest common factor is a numerical answer, 12, which is okay. Let's look at another examples. 13 s cubed r cubed and 29 s r to the fifth t squared. Now I see the numbers 13 and 29. From our knowledge, you can try the tree. From our knowledge, we know that these two numbers does not have any factors in common. So our answer will not have a numerical part. The greatest common factor will possibly have variable parts. S and S, I see both S's, then I'm going to go with the one that has a lowest power, S to the first. R and R, 1 to the third, 1 to the fifth, I'm going to take the one with the third power, it's the lowest power. T does not show up on the first monomial, then no T in our answer. Your greatest common factor is SR cubed. One last question, and I'm stressing how to find the greatest common factor between monomials, and I have 6 questions in my webinar on that because this is the building block for what's next. Okay, we have 5 and 12. We know that there is no common factors between 5 and 12. You can do the tree. C and D, I don't see C and D's or X and Y's in both, so there's no common factor, greatest common factor between those monomials. It's none. I just showed you the different possibilities that you were able to maybe see in your practice questions, in your exam. So I hope that this section is helpful for that part of the unit. Any questions? Okay, let's go to the self-check. Find the greatest common factor of two monomials. 30p to the 12 q to the 6 rs and 22s squared p to the 6 q 12. So what I'm going to do is, since I did not want to make my other screen looks awkward here with manual way of displaying exponents, I'm going to keep that screen for about 30 seconds and then switch my screen again to give you the same question, and then you just need to pick which answer. Is it A, B, C, and D without actually seeing those answers on the second screen. So I'm going to be quiet for about 30 seconds to give you a chance to do that question. Okay, I'm going to switch my screen to give you the same question, but this time you're able to share your answer. And actually, the ability for you to enter or input your answers is something good for me too. It's like a feedback for me. If I need to do a better job explaining a topic, or maybe something was missing in my instruction, so that is a feedback for me as well. Okay, the correct answer for this question is D. D is the correct answer. If you look at only the parts that has the numbers on them, 30 and 22, 15 is not the common factor between these two numbers, not 22, not 11, 2 is a common factor. So any answer that does not have a 2 on it would be an incorrect answer. If you are taking the SAT exam or ACT exam, you have that question, for example, you can save your time. You don't have to go all the way and find the final answer. You can just use your skills to eliminate some answers that it's impossible for them to be the correct answer. So the answer is D. If you do the tree method, you're going to find 2 is the greatest common factor, and then the variables with the lowest powers are p to the 6, q to the 6, and s. Now, let's look at how can we factor then binomials. We now looked at how can we find the greatest common factors for monomials. Let's combine everything and give you a polynomial like that. And actually a polynomial, if you remember from Unit 1, it just a bunch of monomials have a plus or minus signs in between them. So we're gonna repeat the same thing that we have done, but we have to keep these signs. We have to keep the operations there. So we arrive at the correct answer. And also, with the greatest common factor being identified as we did before, we now gonna factor out the greatest common factor from the given binomial. So let's do that together. So the first step to factor a binomial that you think has something in common between its two terms is to identify the greatest common factor. So again, we are repeating everything we have done, 25 and 75. I know from looking at these two numbers that 25 is the greatest common factor between 25 and 75. I need the variable part of my greatest common factor. I see a and a, the lowest is a to the third, so I'll take that. B to the seventh and b to the second. So b to the second would be what I'm going to choose in my greatest common factor. C to the first or c to the second is going to be c. This is my greatest common factor, but this is not how we factor. It's just only one step. What we want to do to open parentheses like that, divide each monomial over the greatest common factor and put the quotient here inside the parentheses. Let's do that together. And if you go back, if I'm not mistaken, if you go back maybe to Unit 1, it showed you how to divide monomials. We can repeat that and remember that together while we're doing this question. So divide 25 over 25 is a 1. We do not write 1 in algebra. a to the third over itself, it's a 1, nothing still. B to the seventh over b to the second. Remember, when we divide two same variables with different exponents, we subtract the exponents. So we're going to have b2, the 7 minus 5 power. Sorry, 7 minus 2 power. So that will give you b to the fifth. So just want to write the note here, b to the seventh over b to the second is actually b to the 7 minus 2 power, which is b to the fifth power. We subtract powers. Same thing with the c's. C's to the second, and here we have a power of 1. 2 minus 1 is 1, so it's going to be a c. So the first term that appears inside our parentheses is the quotient of dividing the first monomial over the greatest common factor, b to the fifth, c. Do not forget the plus sign. It has to stay in our answer. 75 divided by 25 is a 3. A to the 10th over a to the third, 10 minus 3 is 7, so a to the 7th. B to the second over itself, it's a 1. C over C, it's a 1. So this is how you factor. So this is factor number 1, which is the greatest common factor, and this is factor number 2. So these are the set of factors of this binomial. I know it's confusing, too many exponents and division and variables and parentheses and addition and multiplication. I know it is confusing, but by practice, you will get the hang of it. Let's do another one. 32, x squared y to the fifth z squared plus 42 x to the fourth z. Factor this binomial. So the first thing that comes to my mind is the greatest common factor. Find the greatest common factor first. I have 32 and 42. Well, this one is tricky. So you may want to do the tree method. When you do the tree method, you're going to find out that 2 is the greatest common factor between 32 and 42. Let's do the variables. What would be the one that appears in the greatest common factor of the x's? So I have to the second, to the fourth, x to the second would be the one with the lowest power. Y to the fifth and no y's. No y's then in my greatest common factor, z to the second and z. Then z would be the part of the greatest common factor. So this is the greatest common factor. I'm not done. I need to factor. Factoring means that you need to divide. Divide each monomial over the greatest common factor. 32 divided by 2 is 16. X squared over itself is a 1. Y to the fifth over nothing over 1 is itself. And then z squared over z, 2 minus 1 is 1, so it's d to the first. And then I cannot forget our plus sign. And then 42 divided by 2, 21. X to the fourth over x to the second. That would be x to the second because 4 minus 2 is 2. And then z over itself is a 1. So these are the factors. This is factor number 1, and this is factor number 2 of the given binomial. That's it. The answer looks, it's not in simplest form, or they're more into it to simplify it, but this is your answer. 2 factors. Any questions? Anything that's confusing or did not match what you've read in your study unit if you have done so already? Okay, let's move on then. A self-check, the same thing. Factor the binomial 26 is to the 6th, t to the third, u minus 44su to the second. What should you do? I'm going to keep that for 30 seconds. I'm going to give you the chance to work on it and then change my screen to give you the chance to enter your answers. Okay, I'm gonna switch my screen to give you the same question with the answered letters A, B, C, and D. Which one represents the factors of the given binomial? Okay, I'm going to share my final answer. The answer is B. B is the correct factoring of this binomial. Whenever you get the recording, you want to pause this video on that question if you didn't get it correct and do it step by step. You want to use the tree method. You want to do the GFC, the GCF slowly and figure it out, divide, take your time, and then see if you get the answer as B. If you do not know how did we get the answer B, you can email your instructor. I'm going to show you at the end how do you email your instructors. Okay, let's then look at how then can we factor a polynomial. This polynomial has 1, 2, 3, 4 monomials. The same thing. It's the building blocks that we have learned at the beginning of the webinar that we'll keep using over and over again. The only thing with that is with too many terms in the polynomial, students gets overwhelmed and confused. We're going to stay doing our rules, we're going to follow them closely, and we're not going to care much about how long the polynomial is. Okay, so let's move on to the number part. We have 2, 3, nothing common between 2 and 3 except 1, which is 1 is not going to be something useful to us. So anything other than 1 would be a factor. Nothing there between 2 and 3, and 5, nothing. All of them are prime numbers, by the way, and 3. So there's no number part in our greatest common factor. Let's look at the variables. We have x and x and x and x, so x appears in all 4 terms. Which one is the lowest power? is only x to the first, so that would be part of the greatest common factor. We see y and y, just want to make sure it's common, and then which one has the lowest power is only y to the first, and this would be your greatest common factor. You're going to divide over this. You're going to divide each term over this term. So I'm going to have a parentheses opened, and then I'm going to divide. 2 over 1 is a 2. X squared over x is an x. Y over itself is a 1. That's it for the first term. Term number 2, 3 over 1 is 3. X over itself is a 1. Y squared over y is a y. Minus 5 over 1 is a 5. X over itself is a 1. Y over itself is a 1. So 5 is the third term in our second factor. Minus 3 over 1 is 3. X to the fourth over x is x to the third, because 4 minus 1 is 3. And then y to the third over y is going to be y squared. So this is the factoring. That's it. This is factor number 1, which is the greatest common factor, and factor number 2 is everything else here. That's it. Another question of that kind. We have a polynomial. We have now numbers that we suspect that we have a greatest common factor for. 16, 44, 48, and 4. 4 is the greatest common factor. If you're not sure, you can do 4 trees, one for each number, and then find the common factors and then multiply them. That would be the greatest common factor between 16, 44, 48, and 4, which is 4. Now let's switch to the variables. X appears in every single term. So x would be there. Which power though? We have 2 and 1. So 1 would be the lowest power. So x would be part of our greatest common factor. Y and y, there's no y's in the last two terms. So y is not going to be there in our greatest common factor. So we're going to open our parentheses and divide. 16 over 4 is a 4. X squared over x is an x. Y over 1 is a y. Plus 44 over 4 is an 11. Y over 1, there's no y's there, so it's going to be a y. X over itself is a 1. Minus 48 over 4 is a 12. X over itself is a 1, so 12 is a third term. Plus 4 over 4 is a 1. X cubed over x, 3 minus 1 is 2, so it's going to be x to the second power. That's it. This is how we factor the given polynomial. Any question? Okay, let's move on to a self-check. You have a polynomial. You have 4 terms in that polynomial. Find or factor this polynomial. I'm going to keep it again for 30 seconds, then switch my screen. Okay, I'm going to give you the question one more time with a chance to share your answers with everyone. Which answer is the right answer? A, B, C, or D? I'm going to wait for a few seconds for everyone to have the chance to share their answers. If you want to share your answer, you can do that in the next few seconds before I end the question. So the final answer, the right answer for this question is A. A is the correct factor. They are the correct factors for this polynomial. You're going to find out with the tree method, or if you just notice that all of these numbers are multiples of 5 and 5 is the greatest common factor, then 5 should be part of our answer. Let's look though at the variables. We have Q and Q. No Q's there, so Q should not appear in our greatest common factor. Let's see the R. R is there, but not there. That's it. It's not going to be part of our answer. What about the S? S is not there. S is not common, so there is no S either. So there is only a number in our greatest common factor. Divide each term over 5, and whatever you're going to get there, it will make up the second factor of the polynomial. So this is factor number 1, and this is factor number 2. Okay, let's move on to another way to factor a polynomial. So this one is a little bit tricky, and I tried my best to find questions that would best explain this method. In this method, if you look, we're gonna just read the question as it's a question. It's not part of a lesson. Let's look at the question as numbers and variables without having in our head to use a specific method. We just want to conclude the method and when do we know to use that method. So the first thing I'm going to do, I'm going to assume I'm going to use the greatest common factor method that we have been using so far. So I have 6 and 2, 15 and 5. Okay, but the variables there, I have x and x and x and no x. Okay, and I have 2 with y's, but there is no y's on the other first 2. What I'm going to do is I'm going to think about 2 terms at a time. 2 terms at a time. So I'm going to think about the 6x squared plus 2x. Am I able to factor these two using a 1 greatest common factor between these two, only ignoring the second part of the polynomial? And the answer is yes. 2 is the greatest common factor between 6 and 2. And also x is part of the greatest common factor. So 2x is the greatest common factor between the first and the second terms. Now divide, because remember we're factoring our polynomial. 6 over 2 is 3, and then we have an x plus 2x over itself is a 1. So we're going to write the 1 in this case because there is no variable multiplied to that 1. I was able to factor out a greatest common factor from the first 2 terms. What about the other 2 terms? Well, I can do that. I can do the plus sign has to be there. Be careful of that. That's a common mistake. And then I'm looking at the 2 terms and I know that 5 is a common factor, the greatest common factor, and also y. Let's divide each term over 5y and see what we get. 15 over 5 is 3, x over 1 is x, y over itself is just 1, and then plus 5y over itself is a 1. Now let's look at the line here. Do we see anything common between this term? Remember, 2x times 3x plus 1 is 1 term. They are not 2 terms anymore. This is 1 term and this is 1 term. 2x is multiplied times 3x plus 1. 5y is times or multiplied times the same thing, 3x plus 1. I can treat these 2 terms as if they are multiplied to the same value. What I'm going to do is I'm going to say, well, let's take 3x plus 1 as a common factor because it's common here and there. Let's take it. So take it out. 3x plus 1, and the way we're going to take it out is to divide. Divide the first term over the common factor. 2x times this term over this term itself. That will give you what? 2x plus, we cannot forget the plus, 5y times this over that thing itself. So this over that is a 1. So I'm left over with 5y. This is your final answer. So what I did is I factored twice. Once I just thought about these two terms as being common, they have something in common. I took out the greatest common factor, divided, did the same thing for the other part of the polynomial. But I noticed that this part and this part are common, so let's take it out. Let's factor it out. So we did, and then divide. Divide this over that, and divide this over that. And you have now two factors. Now, this method in your study unit, they call it polynomial factoring or polynomial factors because your factors actually are two polynomials or two binomials. Or if you go to online and you want to have more practice on this method is commonly called factoring by grouping. You are grouping. You're grouping this and factor something out, and you're grouping these terms and factoring something out. So this is factoring by grouping if you want to look at outside resources. Let's do another question. I know this one is tricky and I get the most questions on them, so I'm having multiple questions here on my webinar about this method. Okay, so let's look at the question. We have a polynomial. I know that there is something common between these two, a y and a y. Let's try. It's just a trial and error. I'm going to try to factor out the greatest common factor between these two and see what's going to happen. So I have 2. It's the greatest common factor between 10 and 2. I have also x, and I have y. Divide. 10 over 2 is a 5, and then I have an x, and it's going to be a 1 plus 2xy over itself is a 1. And then I'm going to do the same thing, and I hope that I'm going to get something times 5x plus 1. Okay, so I have the plus sign. There's no common factor between 5 and 1, so there's no numbers there, but we have x squared. So divide. 5 over 1 is a 5, x plus 1. And our hope was true. We have 5x plus 1, 5x plus 1, common factors, common polynomial. So factor them out. Take these out, 5x plus 1, and divide. The first term over this will make you left out with 2xy plus, don't forget the plus sign, and then this divided over that, these will cancel out, so you only left out with x squared. So your factors are 2. 5x plus 1, that's a factor. The other factor is 2xy plus x squared. Any question on these? By practice, you'll get better at it. By practice, you will know which factoring method you need to use, or if I have to factor over multiple steps, or that's it. If I'm going to factor this only way, that would be the final answer. It's by practice. So do not overwhelm yourself now on how to identify which kind I have to use. Just try to practice factoring and try to do it correct, and you will get the hang of it. You will know as you work in the question, some signs you will encounter will tell you, oh, this is factoring by grouping. This is not just a normal factoring. One last question for you to have there in the webinar, since it's one of the toughest methods to factor. So we have a polynomial. I'm gonna think about factoring by factoring out polynomial factors. So I'm gonna try to factor out a greatest common factor and a greatest common factor. 12 and 2. 2 is a common factor, the greatest common factor. A also. B is not because it's not shared here. So divide. 12 over 2 is 6, and then I have an A, and then plus I have 2AB over this, that would be a B. And then I have to bring the plus sign down. I have 24 and 4, so 4 is a common factor. And I have a B and B, then B is the greatest common factor between B squared and B. Divide. 24 over 4 is 6. And then I have AB over B is an A. I'm now starting to see that this will become plus B, and I hope for that, plus B. Factor out the 6A plus B, 6A plus B, and we do that by dividing each term by this common factor. So I'm going to have 2A plus 4B, and these will be the factors of this given polynomial. That's it. Okay, let's look at a self-check. Same thing, and this would be you have to do the polynomial factor, so you don't have to think now about which kind. Just do the factoring by grouping and see what you're able to do. So I'm gonna again give you 30 seconds to work on it and then change my screen to give you the possible answers. I just want to remind you that if you have a question, the raise your hand feature does not work. We only get questions through the chat box, or the the questions box. This is the only way that you're able to communicate your questions. Okay, I'm gonna switch my screen to give you the actual question, and you're able to choose your answers here. Okay, I'm gonna share my final answer then. So the right factors for the given polynomial is C. Let me know if you need to see this question done today, or you would rather do it on your own when you get the recording. So I would use the time towards the other topic that you have left in the webinar. But if you need me to do the question, show you how to do it, just type yes or one, so I would know that at least I have one of you wants to see the question. Okay, I'll do it for Asia. So I'm going to group two terms at a time. I see 3 and 3, so 3 is a common factor. X cubed and x squared would be the common factor. Y and nothing here, so y is not going to be part of our greatest common factor for these two terms. Divide. 3 over 3 is a 1, and then we have an x. 3x squared over 3x squared is a 1, but we have a y, so we have x plus y inside the parentheses. Bring down the plus. This is a common mistake. 2 and 2, then 2 is a common factor, the greatest common factor. We have y and y squared, then y would be the common factor, and there's no x's there. So that's it for the greatest common factor. Divide. 2 over 2 is a 1x, and then y over y is a 1, plus 2 over 2 is a 1, y squared over y is a y. Yes, it is factoring by grouping, so take out the x plus y and divide each term over this. So you're going to have this part, 3x squared plus 2y. So C is the right answer. Okay, let's move on to the last topic in today's webinar. We may run over time. I wanted to spend my time and give the appropriate time for those topics, because they are the essence of algebra. If you do not know how to do these things later on when you take any algebra class in college, or maybe algebra 2, if you do not know how to do these things, you will have a problem. So factor the following binomials. X squared minus 16. Something is so special on that binomial. This is a perfect square. And this is a perfect square. Remember that table or that chart that we have from the other webinars, 4, 9, 16, 25, 36. These are perfect squares. 2 squared is a 4. 3 squared is a 9. 4 squared is a 16, and so on. X times x is x squared, and that's why also x squared is a perfect square. When you have a binomial, that's a rule. When you have a binomial that has two perfect squares subtracted, then you have difference of two perfect squares binomial, and it has its own special way to factor. And that is an equal sign that you take the square root of the first minus the square root of the second. That would be your first factor. And then take the square root of the first plus the square root of the second. That would be your second factor. When you say it out loud, it's hard. When you do it, actually, it's so simple. So you have a difference of two perfect squares. We're going to do it this way. Two parentheses here, x and x, because the square root of x squared is x and x. Once is a minus, once would be a plus. The square root of 16 is 4, so 4 and 4. That's it. That is it. So we're applying the rule. If you have a plus sign in between two perfect squares, you cannot use this rule. This rule only applies with the difference, not the addition or the sum. Number 2, 4x to the fourth minus 121. I see a minus sign in the middle. I see a binomial. I may suspect that this is a difference of two perfect squares. Let's check. 4 is a perfect square. X to the fourth is a perfect square. You know, x squared is x to the fourth. And 121, we know that 11 times 11, or 11 squared, is 121. So we actually have a difference of two perfect squares. How can we factor that? Okay, two sets of parentheses. We have 2x squared, 2x squared. We have a minus and a plus, 11 and 11. Why do we have a 2x squared? Because the square root of 4 is 2. The square root of x to the fourth is actually dividing the exponent over 2. 4 over 2 is 2, so that's why we have 4x squared as the first term in each factor. The same thing, the square root of 121 is 11, once with a plus, once with a minus. Questions? Okay, let's move on to a different version of that rule. 200x cubed minus 50x. Well, it's not the difference of two squares because I have an x here. It's not x squared or fourth or the sixth. So it's not the difference of two squares. All I can do at this step is to factor out the greatest common factor and see what's going to happen after that. 250. 50 would be the greatest common factor. And I have x cubed and x. Well, x is the greatest common factor in this case. Divide. 200 over 50 is a 4. And then I have x squared. Don't forget the minus. And then I have a 1. Look at the binomial inside the parentheses. This is a difference of two perfect squares. Then I need to factor this side more. I'm going to keep my 50x, but I'm going to do the factoring method. 2x and 2x. Once with a minus, once with a plus. The square root of 1 is a 1 and a 1. That's it. So it may look like that this is not a difference of two squares, but when I factor out the 50x, it's apparent now that I need to factor out further and apply the difference of two perfect square method. And that's it. So in this case, this binomial has three factors. Factor number 1, that's factor number 2, and that's factor number 3. Okay, One more example, 48a squared b minus 12b. Nothing to do in this case other than factoring out a 12 and factoring out a b. And divide and see what's going to happen. 48 over 12 is a 4. And then a squared. And b, just step 1 because b over b is a 1, minus 12b over 12b is a 1. Once again, in the parentheses, I have difference of two squares. 4 is a perfect square, a squared is a perfect square, 1 is a perfect square, and we have a minus sign. I'm going to go ahead and apply the rule that says that this would be 2a and 2a. Once with a minus, once with a plus. The square root of 1 is a 1 and a 1. 3 factors, 1, 2, 3 for this binomial. Any question? Okay, let's move on to our last self-check. Factor 16x to the 7th y minus 81xy. The 16 and 81 gives you a feeling that this might turn out to be a difference of two squares because 16 and 81 are perfect squares. The problem that we have are in the variables. If I'm able to factor out some variables and make those variable parts perfect squares, then I'm able to go ahead and apply my perfect square rule. I'm going to leave it here for 30 seconds for you to try it out and see. Okay, I'm going to give you the same question now, and you'll be able to share your answers. Which set of factors are the right ones for the given binomial, A, B, C, or D? Okay, I'm going to share my answer, and as I said, if you don't have time now to work on those questions at your pace, you can pause the video when you receive the recording and work on your pace. Have a piece of paper, get your tools ready, and work on those questions. Okay, so the final answer is A. A is the correct answer. I'm going to go ahead and do that question because, again, this is one of the trickiest ways of factoring when it's your introductory course in algebra. So we have 16x to the 7th y. So I'm going to factor out because I see a y and a y. So y would be part of my greatest common factor, and x2 would be there. I want to keep 16 and 81 because they are perfect squares. So I want to keep them there. So divide is going to be 16 x to the 6, which is an even power that's a perfect square. And then y over y, just a 1, and I have a minus. It's a difference, see? And then I have 81 over 81 times 1, which is 81. 16x to the 6 minus 81 is a perfect square. I'm going to keep my first factor as is. I'm going to open two parentheses, 4x to the 3rd, because 6 over 2, remember, is 3. And then 4x to the 3rd. 1 is a minus, 1 is a plus. The square root of 81 is 9. So I have a 9 and I have a 9. So that is your answer, this answer. Okay, I'm over with my math part of the webinar. We looked at different ways of factoring binomials and polynomials. We learned how to find the greatest common factor. We also learned that whenever you are not able to determine what method you should use. Is it grouping? Is it the perfect square? Which one? But you have some common factors there between your terms. You want to go ahead and do that first step. And then later on, things may come up, and then you realize that maybe you want to do the perfect square factoring or factor by grouping, and so on. Before the exam, you want to read your lessons. You cannot just depend on this webinar or your previous knowledge on how to factor and just go ahead and take the exam and expect yourself to pass. You may pass. I'm not saying it's impossible. You may. But the safest way to do and the right way to do it is to study first, read the readings, do the practice questions or discover more questions, however they call it in your lesson. Check your answers to those questions. We provide you with the answer keys for those practice questions. If most of your answers are correct, it is a sign for you that you are good. You are good to go for the exam. Most of them are incorrect. It's a sign that you should not attempt the exam. You can use this webinar, watch it. You're going to receive the recording tomorrow. And also, if you want extra help, it's not required. You want to go to khanacademy.org, go to the subjects. It's on the top left corner of the page. Go to Algebra 2, and under Algebra 2, they have a lesson on polynomials. They discuss different ways of factoring. You can choose the one that you need help with, and you can watch the videos and do the quizzes, and that way you can have extra help if you want. Ways to communicate with the school for help. You can call the school during normal operation hours. You can schedule an appointment with one of the instructors or TAs using this link. This link will get you the different courses there. You can choose your course, what time, what day, and you schedule that, and somebody will call you back on that day. You can text message if you have a brief question on your learning. You can text message this number and type in learn. That will get to the education department if you have an academic question. If you have a general question or a financial question, then you want to type coach for general questions and help for financial questions. That will get you to student care or student services. How can you email your instructor if you have an extensive question, a long question, detailed question, and you're expecting a detailed answer? You can email your instructor. Now, I have this screen divided into two sections, 1 and 2. Some of you have that platform, and some of you have this platform. The lessons are exactly the same, everything the same. The exams are exactly the same. The only thing is just the interface, the appearance. So choose which account you have, either this one or this one. Follow the steps here I have in the little squares. You'll be able to send your instructor a question. And thank you for attending and interacting with me here with your questions and the self-check questions within the webinar. Also, I will appreciate it if you take a survey. It's only 3 questions, short answer questions, just to let me know how did I do in the webinar, if I need to improve or I need to add something I didn't think of adding. Students who did not attend the webinar are able to take the survey as well with the link that will be sent in the follow-up email. I will appreciate it so much. If you have any questions, general questions or any questions in the webinar, I can wait for another minute or two to wait for your questions. So if you have them, please type them in the questions box. Okay, well, if you think then of any questions later on after we finish this webinar and end it, you can use text messaging, you can do the emails, and that way you're able to get help. Good luck in your exam, and I wish everyone do wonderful on your exams, and thank you again for attending.